And Chris Horn is a senior researcher at Secure Decisions. A little bit about those companies. Secure Decisions does cybersecurity R&D, and especially in application security. And then we transition the technologies into operations. And in the case of one of our research projects, it was so successful that we created a commercial company called CodeDX, and that commercializes the results of our research. So today's talk is going to have 4 parts to it. The first part is going to answer the question, why should we investigate human factors that affect code quality and security? And then part 2 is going to talk about how we do that research. Part 3 is the crux of the presentation, and it is on what we have discovered thus far, both in our own research as well as research that's been done in academia and industry. And then last, we're going to wind up with what are some of the lessons learned from other domains, non-software domains, non-security domains, that we know affect human performance and safety, and that we may be able to apply to software engineering. So let's start out with the why. Why should we investigate human factors that affect code quality and security? Well, we all know that software vulnerabilities are a major gateway to breaches. In fact, in the information industry, over 90% of the breaches in the information industry are traceable to an exploitation of web app vulnerabilities. So it's really important to find and discover these vulnerabilities before an attacker does. Unfortunately, software vulnerabilities remain undiscovered for a long time. So if you look at Heartbleed, it took 2 years to discover. If you look at the vulnerability in Apache Struts that was exploited for the Equifax breach, it was in that code base for 4 years before it was discovered. Now, I'm putting discovered in quotes because it may have been discovered and not reported, okay? It became publicly disclosed 4 years after it was originally inserted. And academia has actually looked at a number of open source projects, and they found that on average, a vulnerability remains unreported in open source for an average of 2 years. That's a really long time for a vulnerability to be there, and potentially could have been discovered and exploited before it was reported. Now, there are ways to find these vulnerabilities before the attackers do. One way is static application security testing. I think everybody here is probably familiar with SAST tools like Checkmarx and Fortify and AppScan. And open source ones as well. What you may not know is that the tests that were done by the National Institute for Standards and Technology, as well as NSA, found that a single SAST tool finds only about 14% of the weaknesses in a code base based on the common weakness enumeration. And actually, each tool finds almost a unique 14%. So that in some find 25%, some find 8%, but on average it's 14%. And you have to actually combine them in order to get good vulnerability coverage. So another way to find these vulnerabilities is to do code reviews, to do manual code reviews. And the problem with that is that manual code reviewers are looking at this expanse of software. Like, where do they start hunting for the weaknesses in the code? So where would you hunt for vulnerabilities in code? We believe that human factors may play a role and may actually help manual code reviewers to find vulnerabilities or security weaknesses in code before production. So could you search a code base for security issues based on the characteristics of the developers who developed the code? What about the characteristics of the teams that developed the code? Or maybe when the code was written? Time of day, time of year. Or what about where the code was written? Was it written by Is it written in a certain time zone? Or was it written by a team that was distributed across continents, for example? So these are what we call human factors. Human factors are properties of people and their environment that affect human performance. And they come in a variety. So there are psychological human factors. At an individual level, this may be something like your ability to focus your attention, or how good your short-term memory is. At a group level, a human factor may be how well does the group collaborate or make decisions together, or even cultural norms. There's also physiological factors. So this can affect human performance, something like fatigue, or something called circadian rhythm. Let me talk a little bit about circadian rhythm. It was actually the topic of my doctoral dissertation. And circadian rhythm are the diurnal cycles that your body goes through during the course of a day. And human beings basically follow a very similar pattern. And there are certain chemicals in your body that change over the course of the day, and those chemicals are related to your alertness or arousal level. And that can actually affect human performance. And then there's environmental factors, such as, are you in a distracted environment? Or is it too hot or too cold? Or is the lighting good or poor? And all of these factors are considered in almost every safety critical system that is designed. So why wouldn't it be part of software engineering? Software is behind so many safety critical systems. Why wouldn't you want to look at human factors that affect the performance of software developers? And that's what we're doing. So now I'm going to describe how this work is done. So I'm going to review some prior research and then talk about our research. So the way that this is done in academia, and I have a logo up there for Rochester Institute of Technology. They're one of the universities that does a lot of this work. So what they typically do is they study open source, because that's freely available. And so they look at an open source repository, and what they typically do is look at something historically. They go back in time, and let's say they look at Chromium. And they go back 10, 15 years, and they infer human factors from the code base. So if you want to know about team size, they'll count the number of contributors to a file. If you want to know about time of day, when the code was written, they'll look at the local time of commit. And you can look at it in some open source repositories, not in everyone. If they're looking at attention, they may look at how much a contributor in the file is looking at, is also contributing to lots of other files. Are they focusing their attention or distributing it? So these are the kinds of things that they look at. And then they're the predictors, they're the human factors. And then on the other side, they're looking at security outcome. And so they're looking at publicly disclosed vulnerabilities. And what they do is they make a pile of files that have publicly disclosed vulnerabilities and a pile of open source files that don't. And then they say, what are the differences between these? Are there certain things that really discriminate this vulnerable set from the set that doesn't have vulnerabilities? Now, there are other studies of proprietary code. So Microsoft, AT&T, Nortel, there's a number of companies that will actually study their developers and occasionally publish the results. And I'm going to talk about one of those in a few minutes. Chris and I are performing research under a DARPA R&D contract. DARPA is the Defense Advanced Research Projects Agency. They are the premier DoD R&D organization. They have a $3 billion a year research budget, and they did invent the internet. It was called ARPANET. And they are funding us to expand on this research to find out how human factors affect secure code development, both in open source and proprietary environments, and to study human factors directly. So let me tell you a little bit about how we do that. The first way is pretty much what I said before. You look retrospectively at a code base and you try to infer things from its history. And in open source, you then look at those things and relate them to publicly disclosed vulnerabilities. But if you give us a code base from your company that was written in a proprietary environment, we'll ask you for other information. For example, we'll say, well, okay, here's the list of all the developers, but can you tell us about their experience or their training? We might look at time card information to see how many hours did they work, and then correlate whether or not working a lot of hours relates to the introduction of quality or security weaknesses in the code. We also are doing something, and by the way, most of what I present today is going to be about the first item. The second thing we're doing is studying developers as they code. We're instrumenting their environment, and we are, like they come in the morning, the developer turns on the workstation, and we say, how much sleep did you get last night? And we also have them instrumented so that we can see how many windows they have open, where their focus of attention is. Are they somebody who flips back and forth constantly between 5 different windows, or they focus their attention on one? We also ask surveys during the course of the day about how many interruptions have you had. We try not to ask that too many times, lest it be an interruption. And we ask about what their fatigue level is, what they're listening to. Because there's research that shows that if you're listening to voices, to conversation, that it impedes your ability to do certain things versus white noise or music. And then the other type of research that we're doing is vulnerability history analysis. And that is where we take, let's say, open source, we look at a publicly disclosed vulnerability. And we look at all of the factors that were around it at the time that it was discovered. Then we go all the way back in time, usually at least 2 years, to the time when it was first introduced. And we look at that vulnerability contributing commit. And we say, what was going on in the code base at that time? And we try and figure out if there is certain conditions that are likely to be prevalent at the time a vulnerability is introduced. And we also look at the time in between to see were there opportunities to discover it that were missed and what was going on. So hopefully next year we'll be back and we'll be discussing either the current analysis or the vulnerability history analysis. But for now, we're going to talk about the results of the first type of analysis. And so what we do is we take these code bases, and what academics do and other people in industry, and they look at a series of human factors. So we might be looking at the developer's attention or team size or co-location of developers. And then we correlate that to code security and quality. So it might be publicly disclosed vulnerabilities, or we're looking at the results of running static code analyzers. So we look at the number of weaknesses that are in the code. You could also look at bug frequency or failure rates. So that's the kind of relationship, statistical relationship that we're looking for. So what has been found? This is the crux of. So let's talk about team co-location. The question is, does code quality vary with team location? Microsoft did a study of their post-release failures in Windows Vista. And they wanted to see if the teams that were co-located had fewer failures than those who were separated by continents. And they actually looked at people in the same office, on the same campus, in the same region, the same continent, across continents. So what do you think? Does code quality vary? Does code quality predict? Do you think there's a relationship between team co-location and code quality? In the Microsoft study, there was absolutely no difference between the groups, whether they were shared the same office, the same cafeteria, if they were across different continents. And no matter how they looked at the data, it didn't make a difference. But there was something that they found that contributed to the difference in the failure rates. And hold that thought, because I'm going to tell you later. I know it's me. Right. How about time of day? Would the quality vary based on the time of day when code is committed? Yes or no?
Yes.
Yes. Late night commits have more bugs than morning commits. The study was done that showed that commits that were code that was committed between midnight and 4 a.m. was buggier than code that was committed between 7 a.m. and noon. Now, why is that? Yeah?
Is that confirmed confirm that morning people are better.
So it could be because they're tired. It could be because they're tired. We don't know why. But remember I was telling you before about circadian rhythm. So you may all look at this and relate to this. So you know that mid-afternoon dip that you feel, siesta time, right? Great. We're approaching the mid-afternoon dip. Performance does go down. And there are more accidents at about 2 o'clock in the afternoon. It's not just because, oh, you know, you got a full tummy. No, it has to do with the fact that the catecholamines in your body are dipping and you are less stimulated, less alert, less aroused. And then it comes back up in the afternoon, and then it plummets at about 10 o'clock at night and stays down there until about 6 o'clock in the morning. And so if you look at that and then you look at the buggy commits, it's possible that circadian rhythm may be playing a role. And actually, circadian rhythm is a very, very stable thing across human beings, and very few change, even despite their sleep patterns. So if you have somebody on work schedule who works the night shift, most of them, their body doesn't actually adapt. We're wired. Some of them do, but most of them don't. Don't get operated on at 2 o'clock in the morning. Right? Okay, so let's talk about attention. Now, when you're looking at a code base that has been around for a long time, and you're looking at it historically, you don't know what the developer's attention level was, but you can infer it. And there's something called unfocused contribution. Unfocused contribution goes up when a developer is not just changing one file, but he or she is working on a lot of files simultaneously. It also goes up when a number of developers are contributing to one file. So basically, a file has unfocused contribution if nobody's giving it his or her individual love and care, right? And so do you think that this makes a difference in terms of quality or security? Yes or no?
Yes.
Yes. The more unfocused contribution, the more insecure a file. If you look at Chromium and Apache, now remember I said that what you do is you take the files and you say, Chromium files that have vulnerabilities, Chromium files that have no publicly disclosed vulnerabilities, and you look for the comparisons between them. The ones that are vulnerable had a lot higher unfocused contribution. The developers of those files were busy doing a whole bunch of other things. Now, we also did some of our own research on this, and instead of just looking at publicly disclosed vulnerabilities, we actually looked at the results of static code analyzers. We wanted to see if there were more quality and security weaknesses in files that had higher unfocused contribution. And we looked at 2 open source repositories, and we looked at 2 proprietary repositories. And we found that as unfocused contribution increases, so does the number of static analysis findings as well. So really, if you want to decrease the number of weaknesses as found by a SAS tool, you need the developers to really focusing on just a few things at a time. Okay, number of developers. So a lot of people say many eyes make good security. What do you think? Does the number of developers make files more secure? That's right. Well, remember the Microsoft study? I said that there was one thing that accounted for the failure rates across everything. It was the number of developers. The more developers on a team, the more failure rates. And in fact, we see that in Microsoft, there were more developers led to more pre- and post-release failure rates. We also have found that more developers create more security issues. So we looked at, there's a number of different academic studies. One of them was in the Linux kernel. So remember the pile with vulnerabilities and the pile without vulnerabilities, right? The pile with vulnerabilities, one of the big differences was that if you had 9 or more developers of the Linux kernel, you were 16 times more likely to have a vulnerability than if you had fewer developers?
With the same volume of code?
Good question. They did not look at that in these studies, and one of the things that we're doing is we're going to be looking at defect density. Okay? But a very good question. Chromium. But files with 9 or more contributors, 68 times more likely to have a vulnerability. Apache, 9 or more developers, 117 times more likely to have a vulnerability. So then we looked at it and said, well, you know what? That's publicly disclosed vulnerabilities. What about static code analysis findings? So we did an analysis of 2 open source and 2 proprietary code bases. We looked at the source code files and found that more developers contained more, that the files that have more developers contain more static code analysis findings, meaning more weaknesses. So why is that? Right now, it could be purely volume. One of the thoughts is that it's something called the bystander effect. You know, if 2 people observe something, one of them says, well, did you see that? We got to do something about that. You get 9 people, and everybody thinks that somebody else has done something about it. So it's possible that it's something called the bystander effect. So there seems to be a lot of evidence that number of developers does affect security, but what about quality? Chris is going to take it from here.
Thanks, Anita. So when you guys said no, maybe the number doesn't matter, you were also correct, because other research has not found the same thing. So in this, we have 3 studies here that are papers that I can talk about. So this one, they studied 4 open source projects, and they looked at the commit behavior, right? And they looked at, on those commits, how many people, sorry, I lost my train of thought. How many people committed to the individual line of code that had the defect on it? And what they found was that the lines that were modified by fewer contributors actually, the lines that had been fixed, the lines that had been fixed, meaning that they had a problem on them, had been modified by fewer developers, which suggests that actually that it's when you have a single developer that you get vulnerabilities on the line. So that's a smaller number of developers. In a study of telephone switching software, this was Lucent, they found no correlation between the number of developers and the bug fixes. And AT&T, also telephone switching software, found they tried to build a model where they take different features and use that to predict where the vulnerabilities occur, or in this case, quality problems, crashes and things like that are going to be. And what they found that when they added in the number of developers on the file, it basically didn't help their model at all, which suggests that it just doesn't matter, right? And so why is there a difference between quality and security? And some people have studied that also, and they seem to be different types of problems, right? So they're just a little bit different, quality and security. So we think that might explain some of the difference from the results that Anita showed you from what is on here. Yeah. So another question that people often have is look at the amount of developer experience, right? So we all kind of equate, like the more experienced you are, probably the better you are at your job. And this is measured in the research with the amount of, because we have commit data, right? We have limited amounts of data. Nobody went and asked all those developers, like, how long have they been working and that kind of thing, right? But we can look at the commit data and we can see how long they've been committing to a project, and we can see how many commits they've been making. So both number of commits and time duration. And so do you guys think this matters?
Yes.
Indeed. So the more experience a developer has, usually measured in terms of their commits or their time duration on a project, higher quality software, in other words, the fewer the problems. Microsoft did a study where they were looking at the pre and post failures, and they found, so this is based on the sort of percentage of commits that a developer is responsible for. So if you look at all the commits made to a file, all the different people, and you kind of allocate those commits to different people. The people who are minor contributors, they're only chipping in here and there. Those files that have more minor contributors are having more problems, right? So because those people don't have as much experience on the file. That's what that's suggesting. And also in a study of the Linux kernel in Postgres, the most experienced people, the people who had the longest amount of experience committing to those files, were the ones introducing fewer problems. And what was interesting here was that they actually found that, it's slightly unrelated, but it's just interesting, that the people whose commit patterns suggested that they were doing this for a living were introducing more bugs than the people who were doing it more on a volunteer basis. Which just kind of suggests that there might be differences in the open source and the proprietary software, which is one of the reasons we're studying both types of repositories. And then this question here is about how developers interact. So one of the ways that developers interact is basically in the code base, right? There's a lot of meetings and other types of face-to-face interactions and email and discussions that happen that are not captured by today's development systems, or at least the ones that the researchers have access to. But we can look at their commit data, and we can look at whether or not a developer is editing code that was last modified by somebody else. And so in this, I guess I'll ask. So do you think that when this idea of interactive churn, so if basically, do you think that when somebody's editing somebody else's code, that leads to more problems or not? So when we have these higher measures of interactive churn in the files, which basically means that people are editing code last touched by somebody else, we see more vulnerabilities. And so in Chromium, the web browser, and the Apache web server, when we do that, the difference in the publicly disclosed files, right, where we look at files with publicly disclosed vulnerabilities and files without, the files with the vulnerabilities have higher measures of interactive churn. And then there wasn't a question here where there's one paper that it's also related to how developers interact. And they were actually looking for the sequences of interactions between developers. So if people are introducing the same types of defects at the same time, or if somebody's, if it's person A and B, what the sequence of interaction is between fixing and breaking. And it's just interesting that they found that the most common pattern out of all the ones they looked for, it was hugely dominant, was where somebody introduces a vulnerability and somebody else comes and fixes it. And so that's the end of that section. This section is where we can draw lessons from non-software domains. And so there's been a lot of research that shows that human factors affects performance and safety, right? So in the transportation field, FAA has a awareness, they have research and awareness publications about 12 factors that they call it the dirty dozen that lead to problems. Same kinds of things exist in medicine and healthcare, and occupational health and safety. So people have studied this, they know that human factors affect performance, and so some of the things that we wanted to call attention to and we think are worth considering in the software engineering domain. One of them, for example, is fatigue and vigilance. So everybody who lives knows that your performance isn't as good when you're tired, and it's been studied too. And so after about 18 hours of not sleeping, your performance on a number of tasks dips to basically to the point where you're near the legal limit for being drunk, intoxicated, right? And so in medicine, organizations have put workload limits on medical residents, for example. Like you're not allowed to do more than 80 hours a week, which works out to about 11 hours a day. And the same kind of thing occurs in transportation, right? We don't allow truckers to drive more than 11 hours at a shot because we know that the risk of an accident goes up. And so when we're thinking about software engineering, maybe it's only at those deadline push times, but maybe we should not be relying on long, uninterrupted hours of work out of development staff, and because that probably is going to lead to more problems. Experience and qualifications is another thing. So in software engineering, there are certifications and things, but there aren't the same kinds of strict requirements about being able to practice a job that there are in other domains. And maybe that's something that needs more attention. So a lot of occupations have very formal requirements. So for example, to be a professional engineer, to design bridges and things like that, you know, you need to go to school for a number of years, and then you actually have to have apprenticeship requirements, and then competency exams, and only then are you allowed to actually design bridges. And even after that, you need to stay continually educated and demonstrate that you're keeping up with what people are learning. Same thing in the military and the government, right? And there are a lot of requirements around having those types of jobs. So that's just something that we think probably needs attention in software engineering too. And then culture. So culture is particularly interesting to me. You know, when I hear a lot of the talks around these conferences, like even at LastCon, a lot of the things that I hear are people trying to influence the culture of their organization. And so I think actually this one is getting addressed, at least, you know, the things that I'm hearing about in talks. And culture is this complex mixture of beliefs and values, attitudes, goals, things like that. There's a lot of things you can read about culture. The summary is it's complicated. And so there's no one thing that defines a culture. But culture is linked with outcomes. So people have done big studies of safety culture. And so you have these sort of big batteries of questions that you ask all the people in the intensive care unit or the hospital. And you kind of triangulate you get a measure of the safety culture. And the research has shown over these big, so the ICU study is actually between different ICUs. And you see that the ICUs that have higher safety culture scores have fewer medical complications and deaths and things like that. So basically better patient outcomes. And the same thing here with this 2-year study. They actually measured the culture with these questionnaires, and then they did things to affect that culture over a couple years and to improve it and to boost those safety culture scores. And those places where they boosted the safety culture score saw improved patient outcomes. So we know that if we positively affect culture, we can actually affect the outcomes that we care about. In software engineering, that's probably security, right? And so it's slow, right? Like we know that with seatbelts even, which has been clearly demonstrated to prevent accident or prevent injury, you know, not everybody's still compliant with that, but it's something that we can pay attention to and manage going forward. So with that, I'll give back to Anita.
Thanks, Chris. So let's wrap up. I hope you believe by this point that we really do need research to identify the human factors that influence secure code development. And we are looking for people who are willing to participate in this research. We're looking for especially proprietary code bases that we can study, because there's a lot of open source out there, but we're not sure if the same human factors are at play in a proprietary work and development environment versus open source. So if you have a code base that you'd be willing to share, we would love to analyze it. And also we're looking for development teams, anything from 3 or more developers, because we would like to be able to look at factors that are at play in that development team that may be of interest to your organization, and we can study them and correlate those human factors to the security and quality outcomes. And if we find a significant correlation, what do we do about it? Well, one of the things about this research is that you can actually modify the software development environment. You can limit the number of team size, for example, or you can not impose so many tasks on the same developer where they have to constantly do context switching. And you can also use these human factors to hunt for undiscovered vulnerabilities. So based on what we learned today, where did you start hunting for code security issues? Code committed after midnight, files with high unfocused attention, files that have 9 or more contributing developers, files where the contributors had the least experience in the code base, and files with the highest level of interactive churn. So we have these slides available. I'll make them available through the CodeDX website. We'll post something about it. We have a bunch of references here. Everything that we talked about has scientific evidence behind it. So we have a list of references. And if you'd like to participate in the research or you'd just like to learn more, that's my contact information and that's Chris Horn's contact information. We'd love to hear from you.